Hello and welcome back to our course. So we are starting with the number systems from this lecture onwards, and you are supposed to make your class notes from starting from this lecture. So pay attention in that manner so that you cover all the topics that are discussed in the lectures and include them in your class notes. So we start with the definition of number system, how we have understood what a number system is, and we go back to our last lecture, previous lecture, where we understood the systems of representation of numbers. So there we defined what a number is. A number is basically something which represents the abstract information of the quantity of something. So the quantity is basically an abstract information of something, like you may say that there are so many apples with a fruit seller. So that so many is a quantity. You buy so much kg of rice, so that so much is a quantity. So these quantities are having are not something which exist in the physical world. However, they are attached very much to these physical objects, and we have a very definite understanding of what we mean when we say there are 9 apples, or when we say it is 2 kg of 2 kg rice, or something like that, or 2.5 kg rice. So we have a very clear idea of the physical thing which we are referring to, like apple or rice, and we have an idea of the number of the quantity of that particular thing existing in the physical existing physically, though that quantity itself is basically an abstract information of related to that particular thing. So so what is a number system? Number system is that particular system which represents this abstract information of the quantity of something. So that particular apple has a lot of different abstract information held within it. The information regarding the quantity of apples or quantity of something is what we are interested in, and for that the number system is a particular system which represents that information. So how does a number look? It consists of symbols. It consists of symbols having well defined quantitative meanings placed in an orderly and pre-designated fashion in order to represent a specified value. So that means we will see in a particular number. If you imagine a number, you all know what numbers are. So imagine a number. In that number, you are basically seeing symbols, each symbols having well defined quantitative meaning, and they are placed in a very orderly and pre-designated fashion. And when they are placed in that manner, they represent a specific value or quantity. This is what happens. You can very well understand in your imagination. I will also show it in the next slide. This ordered set of symbols is called a number. So that ordered set of the symbols, so the symbols placed in that orderly manner is called a number. So let us look at a number and understand what we are trying to say. So this is the number. So you can also see this now as a ordered set of symbols. So there are these symbols. This is a symbol, this is a symbol, this is a symbol, this is also a symbol. So, all these are symbols, and we know what these symbols are conveying to us. So, like this particular symbol conveys the quantity 2, this particular symbol conveys the quantity 4, this 1, this 6, this conveys the quantity 8. So, this we know. However, when this symbol 2 is written as a ordered set of written in that has found a place in the ordered set of symbols like this, then this does not represent 2 anymore. This symbol does not represent 2, the quantity 2 anymore. This symbol represents some other quantity now. So, these symbols have well defined individual meanings. However, when they are placed in a set of symbols in a orderly fashion, in a pre-designated manner, then cumulatively they would reveal the information encoded in this number, the information being a particular value or quantity. That information is encoded in this set of symbols in this particular number. So, that information is the quantity or value which is encoded in this number. So, here what is that pre-designated manner in which the symbols are placed? That pre-designated manner is these positions. So, each symbol occupies a particular position in this ordered set. So, in this ordered set, each particular symbol occupies a particular position, and these positions are pre-designated. So, now you get a full meaning of the so long sentence that we had already saw. So, you are getting a clear idea of this long sentence that I have used in order to define a number. So, you are getting an idea now looking at the number how it fits all together. So, we have a ordered set of symbols, each symbol carrying a particular meaning, and this ordered set, in this ordered set the symbols are placed in a pre-designated positions, in a pre-designated manner these are placed. So, that pre-designated fashion is basically some pre-designated positions are there in which these symbols are placed. So, now when we have a knowledge of each of these symbols, when we have a knowledge of these positions, then with that particular knowledge actually we will be able to conclude, or we will be able to infer, or we will be able to bring out that information which is captured in this particular number, that information being the quantity or the value that this particular number represents. Then only we will be able to do that. So, here in the decimal number system, first let us look into the decimal number system, which we are all very familiar with and which is the easiest one to understand. And after understanding the decimal number system in the general light, we will be moving to understand several other systems of number. So, in the decimal number system, these symbols are called digits, and there are 10 digits in total. In the decimal number system, there are 10 digits in total. So, these digits being 0, 1, 2, 3. So, these are symbols basically, these are symbols, but we know we have a definite idea or definite meaning of this symbol. So, this symbol means 0, this means 1, 2, 3, 4, 5, 6, 7, 8, 9, this we know. There is no symbol for 10, 11, 12, 13, there are no symbols. Only these particular 10 number of symbols are available to us, and these are called the digits. Now, as we place these digits in an ordered set in definite positions, various other quantities will also be, we will also be able to represent various other quantities. So, if we only write a 6 here, this symbol 6 here, that will mean that there is, the value is also 6, the quantity is also 6. If you write a 1, then it will mean there is only one particular thing, one, the quantity or the value is only 1. If I write 1 and 6 side by side, then it is neither 1 neither 6, but it changes to 16. So, there is 16, the value becomes 16, or the quantity 1 6 refers to is 16. However, if we swap the positions, if we place 6 before 1, then it does not remain 1, does not give the idea of 1, does not give the value as 6, does not give the value as 16 also. It gives a new value now, which is 61. So, you see, the symbol matter, the set of symbols matter, the position in which you place these symbols also matter. So, all these are forming, all these are acting together to form the number, to form the number in order to represent a particular quantity or value. So, only that value will get conveyed when you place those symbols in that particular manner. No other values, no other quantities will get conveyed when you use these symbols in that particular manner in a particular number system. So, if you change the number system, that value will also change, that we will see. However, if you are in a particular number system, in a given number system, you have placed the symbols in a particular order, then the value or the quantity that is represented by that number will always remain the same, will always remain unique. Now, what does these positions represent? So, now we are going ahead in order to understand how this number captures the information about the quantity or the value, how it is coded. So, this number is basically like a coding, like a code which codifies that this information about the value of something. So, I want to give you the idea that numbers are codes basically at the very first lecture, because if you look at numbers like that, you will be able to see a lot more than just being remaining in the superficial level of how we normally see numbers. So, even the decimal number is a code. However, it is basically it is a direct code. So, the number and the value remains the same. So, it is like a direct code, but the other number systems, those are not direct codes. So, we have to extract the value or the quantity which is represented by that number in other systems. So, let us go ahead and understand how we can extract that information which is encoded in a number. So, the first point is this: the position of each digit specifies its particular contribution to the total quantity represented by the number. So, the total quantity is basically divided among all these symbols occupying a particular position. So, the position of the digit specifies its contribution to the total quantity represented by the number. and that contribution is basically in decimal number system. In decimal number system, that contribution is di 10 to the power of I, where di is the digit at a position I. So, di, these are all di's. So, di can be anything from 0 to 9 and it can be placed in any position. So, this position, this is a 9 digit number starting from position 0 and ending at position 8. This is a 9 digit number. So, that particular di, you choose any di from here. Suppose you choose 6 here. See here, 6 is occupying the position number 5. We will refer I as the position number starting from 0. So, this is position number 5. So, digit 6 is occupying position number 5, digit 1 is occupying position number 6. So, the contribution of this symbol which we call as 6, the contribution of this symbol is not 6 anymore, but it is 6 into 10 to the power of 5. It is 6 into 10 to the power of 5. So, that is the contribution of this particular symbol in the total quantity represented by this number. Similarly, for 1 it is 1 into 10 to the power of 6. For 3 it is 3 into 10 to the power of 3, because it is occupying the position 3. For 5 it is 5 into 10 to the power of 2 for this particular number. For this particular number, the contribution of each of these symbols are like this. So, any digit you pick up from this ordered set of symbols, you just note what is its position number. You start counting the position from the rightmost digit, which is whose position is 0, and start counting while increasing the position towards left. So, you get the position number. So, its contribution is basically that particular digit multiplied by 10 to the power of that position number, di 10 to the power of I. Now, what is the total quantity represented by any number? Of course, it would be the summation of the individual contributions of all these symbols placed at particular positions. That is all. So, the total quantity is basically summation of di 10 to the power of I. So, you move from one position to another. So, you start from 0th position, move to the, see what is the digit here, write this term. So, here we would write, so for this value of the above number, see I have calculated it like this. So, we pick up, we see the ith position here. What is d there? D is 7, the digit is 7, I is 0, so 10 to the power of 0, 7 into 10 to the power of 0, plus next digit 9, 10 to the power of 1, plus next digit 5, 10 to the power of 2, plus 3, 10 to the power of 3, plus 8, 10 to the power of 4. So, in this way we would cover all the digits that we have in this ordered set or this number. So, we cover all the digits that we have in this number starting from the rightmost digit and going towards the left, and when we have covered all the digits we stop simply. So, and then we add all these things up, and that gives the total contribution or the total quantity represented by this particular number. So, for the case of decimal number system, this is actually very easy to also, you do not have to do this calculation also, you know by looking at the number what the value it represents, but it is not so in other number systems. So, we need to have a general understanding of how we actually calculate the total quantity represented by a number. So, we go forward and try to explore it further. So, the first question I would ask is about that importance of 0 that I had highlighted so much. So, suddenly we do not find that 0 being discussed anymore when I actually discuss the decimal number system. So, the 0 was not used, it seems that it was not used in order to understand how we formulate or how we extract the knowledge about the quantity encoded in the decimal number. So, it seems like that. So, all these great things that I already told you about 0 being the root cause or the self created and all these blah blah blah, so many things that I have talked about 0, conferring it to the status of like the supreme number or something like that. So, what happened to that, or to all those talk? So, where did 0 suddenly vanish? So, that is the question here. So, let us look into the numbers once more and try to understand it in a more deeper way, in a more deep way, so that we can understand where exactly the importance of 0 is. And also I made a comment in the last lecture that 0 enabled the human civilization to move from an ancient number system where we are using a lot of symbols in order to represent various quantities, and the 0 enabled us to use only a finite set of symbols and do something with them so that we can represent all possible numbers. So, now our imagination of numbers or our use of numbers became limitless. Before, in ancient systems, we had to limit ourselves because we did not have so many symbols to represent so many numbers that we could imagine. That was a limitation of the ancient number systems. So, now in the modern number system, we can use a finite set of symbols, as in this decimal number system we saw we are using only 10 symbols, but simply by placing them at different positions we can create a number as long as we can possibly imagine. So, there is no limit to creating numbers, but my conjecture in earlier lecture was that this was enabled by the idea of 0. So, how this is enabled by the idea of 0, that we have not really discussed so far, while understanding how the quantity can be extracted simply by knowing the position of the digits in a number, in a particular number. So, let us dive deep down a bit more and explore it. So, this is what I already talked about, but we need to look at this particular thing specifically. So, this quantity or this thing, this 10 what we are seeing here, which is basically like a multiplier to this digit. So, you pick up any digit from the number, you note its position, you raise 10 to that particular position number. So, if you have the position number I, you raise 10 to the power of I, you do not raise anything else to the power of I when you are in the decimal number system. So, this 10 is very specific to a particular number system, and this specific thing is called a radix or the base of a number system. So, any number system, any modern number system which is represented in this position as a ordered set of symbols, where the symbols are placed at particular positions. So, this is also called positional number systems. So, the modern number systems are also referred as positional number systems because of this mode of representation of the number, where the digits are placed at specific positions in order to encode a quantity or a value. So, in positional number systems, any number system will have this radix very specific to that number system. So, for the decimal number system, this radix is 10. For binary number system, this radix is 2. For octal, this is 8. For hexadecimal, it is 16. Hexadecimal is also sometimes referred to as hex. So, for decimal it is 10, binary 2, octal 8, hexa 16. So, this is the radix. So, suppose this number was a number in hexadecimal system, then instead of 10 we would have to write 16 here. So, each digit would be multiplied by 16 to the power of I, not 10. If it was a number in hexadecimal system, and obviously you can now understand how the quantity will change even though the number remains same. Number, by number I mean this ordered set of symbols. Even though the ordered set of symbols remains same, the quantity or the value encoded in it, represented by it, will change when the number system changes. For decimal it will be something, for hexadecimal it will be something else. And for a general number system, hence, so if the radix is represented as r, if the radix be r, so any general number system where the radix is r, then the value of this number, so suppose this is the number in a general number system of radix r, then the value of this number is basically summation di r to the power of I. So, that is all. So, instead of 10 we write r there, that is all. So, now if I ask you the question, if I give you a particular set of symbols which are basically the number, and tell you the number system, suppose I tell you that it is it has a radix 4, suppose I tell you it is a radix 4, then will you be able to give me the quantity represented by the number? Of course, you will be able to give me, because you will simply have to do this sum. We have to see what is the symbol in a particular position, you have to multiply it with 4 raised to the power of that particular position number. Remember, the position starts from 0, not 1, starts from 0, then 1, then 2, then 3, then 4, like that. So, this is the expression. Now, note that we have used the information on what information did we use in order to find the value of the number. If I ask you this question, what information did we use about, so we had a number, we had a number system, all these things we had the position of the numbers, all these things we had. So, what information did we use in order to find the value of the number? So, if we look superficially, we would say that we have used the information on the digits. What are these digits, 1, 2, 3, like this, what exactly are those digits? We also use the information on the length of the number, because we have to stop somewhere, this summation we have to stop somewhere, we need to know the length of the number, so that we also know, so it is not just stopping, but also knowing the positions of each of these digits. And then we have to know the radix of the number also. We have to know the radix in order to find the value of the number, right. So, all this information we have used, it seems so. However, all these fundamental? So, that is the question. Fundamental means what is the minimum information that you needed. So, are all these constitute the minimum amount of information that we need, or is one related to another? If one is related to another, then one of that is fundamental and the other is a derived quantity. So, I hope you have a conceptual clarity about what are fundamental information or fundamental quantities and derived quantities, similarly fundamental information and derived information. So, but all of these fundamental? No, only the radix or the base of the number system is fundamental information needed to construct the number. So, please remember this, only the radix or the base is the fundamental information needed to construct the number. Why so? Because the digits will always belong to this particular set 0, 1, 2 up to r minus 1. If the radix is r, then the digits in that number system will belong to 0, 1, 2 etc., up to r minus 1 only. It will not include r. If you remember the decimal number system, the digit does not include a symbol for 10, it does not. The digits does not include a symbol for the radix which is 10, it stops at 9, 0 to 9. So, those are the 10 digits, it does not include a symbol for the radix. Similarly, for any number system, if the radix is r, then it will consist of symbols or digits which run from 0 to r minus 1. It will not have r as a digit, it will not have r as a digit. So, maximum value of the digit is r minus 1, or the maximum digit is r minus 1. So, if it is a octal number system whose radix is 8, then the number of digits or then the digits are from 0 to 7, 0 to 7. If it is binary where radix is 2, then the digits are only 0 and 1, and in that case they are called bits, 0 and 1. In case of hexadecimal, the digits are from 0 to 15, 0 to 15, and in that case actually after 9 we start representing with alphabets. We will see that in when we discuss hexadecimal. So, that is the then what becomes the fundamental quantity? The number system, the radix of the number system becomes the fundamental quantity, fundamental information, because the digits will be limited, will be restricted by the by the radix of the system. There will be only r number of digits which will start from 0 to and end at r minus 1. Here in any number system, the first digit which is at the rightmost side is called the least significant digit, which is a least significant bit for binary, and the leftmost digit is called the most significant digit or the most significant bit, MSB, for binary. We have a shorthand for that, LSD, MSD, LSB, MSB. But still we have not talked about 0. Where did 0 vanish? So, in all this talk we are still avoiding that fundamental thing which we had highlighted earlier, that 0 is the enabler of moving from ancient number system to modern number system, but we have still not been very clear about how it happened, how 0 enabled that transformation. So, this is a question now. So, how do you think we were able to decide on any particular radix number? So, any number system we can choose actually now. So, in the modern era, number systems can be as like whatever number system you desire, you can write, you can encode any value or quantity in that particular number system. But how did we come to this point where we can choose a radix number? So, we can stop somewhere actually. So, radix number is what? Radix number is actually making us stop at a particular digit and restricting the use of symbols only till that particular digit. So, if we have a radix r, or suppose as an example, if we have a radix 8, then we are only using 0 to 7, no more digits we will be using. So, only with the help of these 8 symbols we will be able to construct as many numbers as we can imagine. So, this is what the power we have got in our hand in the modern number systems. But how do you think we are able to decide the radix number? So, let us investigate further, and we find that, so again we have made a statement here that 0 makes it possible to use a finite number of digits in a number system, these digits being 0 to r minus 1, where r is the radix or the base. But let us investigate and see how this is made possible basically. So, in any position, so you see, you consider this fact that at any position we can only put any digit from 1 to r minus 1. Actually, it is 0 to r minus 1, but let us suppose from 1 to r minus 1 representing a corresponding value, because 0 is not basically a value. So, if we have to give a value, then we have to place 1, 2 or up, so up to r minus 1 we can place at a particular position. So, if we need, so if I keep on writing this, like suppose here, suppose I keep on writing like 1, 2, 3, 4, suppose I am considering the octal system 7. So, if I have a value of 1, 2, 3, 4, 5, 6, 7, I can use these symbols. But what will happen if I want to represent a value of 8? I do not have a symbol for 8. What we do then? We place a 0 at this particular position and move to the next position and write 1 there. So, when we do that, immediately this number will represent the quantity 8 in the octal number system. Why? Because now your 1 will be multiplied by 8 to the power of 1 plus you have a 0, 8 to the power of 0, this is becoming 8, right. So, any number system of radix r, if we need to represent the value of r, then we put a 0 and carry 1 to the next higher position. So, r is basically 1 into r to the power of 1 plus 0 r to the power of 0, and the number is written as 10. So, I should not call this 10 anymore, right. So, 10 is basically a value or the quantity. So, when we say 10, it gives us an idea of a quantity. However, this is not that particular quantity 10. So, we should start calling numbers really as 1 0. So, if we say 1 0, then we understand 1 is placed before 0, and we have to also have an information of in which number system this number is represented. So, if I say 1 0 in octal number system, then immediately I have a understanding that 1 0 is representing the value of 8. If I say that 1 0 in hexadecimal number system, then automatically I am getting an idea that it represents the value of 16. If it is in binary number system, it is representing a value of 2. So, the same 1 0 is representing different quantities in different number systems, and the speciality of 1 0 is this, that it is representing the quantity which is equal to the radix of that number system. So, 1 0 represents the quantity which is equal to the radix of the number system. So, since we are able to do this only because of this fact that we can break down the entire range of quantities into a limited number of symbols in a particular position, and if we want to go beyond this, then we simply put a 0 and put a 1 at the next position, and we can get the next particular quantity. And if we want to add to this particular quantity, then again we add to this particular position. So, this is the enabler of help of making us use the modern number system. This is the enabler. So, the ability to put a particular symbol in this particular position so that we can move ahead enabled us to construct as many numbers as possible. And what is this particular symbol that we are using in order to move ahead to the next higher position? This symbol is nothing but 0, and only 0 can be used here. Why? Because you are actually vanishing this entire contribution. So, 8 to the power of 0 has a contribution. So, if you put anything else here apart from, if you put anything else but 0 here, it will immediately lead to a contribution, but you wanted to vanish this contribution. You wanted to keep only this contribution of 1 into 8 to the power of 1 and vanish the contribution by the lower position, by the next position to the right. So, this act of vanishing was possible only by the introduction of 0, only by the introduction of the idea of 0. So, that is the importance, that is the significance of 0, and that is where 0 is hiding within all the numbers that you are seeing in the modern world. It is not very explicitly revealed, but if you look deep, if you look close, then you can understand where its significance is and how it contributes in building these numbers. So, the contribution is very subtle, so subtle that you almost do not notice, but when you notice, it is like a revelation. So, so anything which has such a supreme cause, so something of a supreme nature, always has this sort of significance which is very subtle, which is ever present, but it is so subtle that you would fail to notice it in the day to day situations. So, in the day to day observance of numbers, in the day to day dealings of numbers, 0 would probably never come, but when you are all these numbers are ever possible to be constructed because of the invention of 0, or because, not invention, because of the revelation of 0. So, this idea was revealed to the world that 0 is something, 0 is not like 0 has some power within it. So, like 1 0 represents the quantity or the value of r, and incidentally in number system this 1 0 represents the value of 10 basically, since r is 10. So, decimal is a like a direct coding. However, in any number system 1 0 is representing the quantity of r. What is 1 0 0 representing? 1 0 0 is representing the quantity of r square, 1 0 0 0 quantity of r cube. So, as many zeros after 1, the value the radix is raised to that power of. So, it is like that. So, here what is happening actually, so this is the real line. So, all the numbers are in this line. Suppose I consider only the positive real line, because negative numbers is basically a reflection of these positive numbers on this point 0. So, so there is this particular point where we encounter the quantity r. Then after some time we will encounter the quantity r square. Then again after some time, so this is not to scale, we encounter the quantity r cube. So, this is not to scale. Okay. So, all these quantities from 0 to r minus 1, then from r to r square minus 1, then from r square to r cube minus 1 are alike. So, we have as if broken down or separated the entire real line into sets, different sets, where this particular set can be represented by only a single position. So, only the position of 0th position is able to represent this set of numbers. So, in this position, particular position, you can have the numbers from 1 to r minus 1, have these digits placed in the 0th position. In this set of numbers you will need two positions, 1 to 1 and 0. So, in each of these position again you can place all these digits from 1 to r minus 1. For this set of numbers you will need 3 positions, and you will be using again this same symbols 1 to r minus 1 in these 3 positions in order to represent these quantities. So, actually this should be actually for 1 to 0, for 2 positions this entire range of numbers are getting represented, actually these entire range of numbers. For 3 positions this entire range of numbers is getting represented, this entire range of numbers starting from 0 to r cube minus 1. So, if you want to if you have numbers only till this, then 3 positions are sufficient, you do not need to extend your position numbers. But if you want to represent numbers ahead in the number line, then you have to keep adding to the position number. Like here you might have to use 4 positions, but the digits remain the same, they are still 1 to r minus 1, and these digits are the set of symbols we are having in our number system, which we have been able to restrict to r minus 1 only because of the capability of 0 that we have made it possible. It had been made possible because of the capability of 0 to vanish all the lower order position numbers. We can move ahead in our positions. So that I have written down here in this slide. What we are doing with 0 is basically this. We are basically vanishing the lower order numbers. And climbing up a level to form a higher order number. So 0 enables this vanishing. The vanishing is not possible with any other number or any other digit. This vanishing is not possible with any other digit. I hope you got this point. So if you have not got this point, you again go through it and make certain that you have got this point, because this is a very significant contribution of 0 in our modern number systems, and if you understand it, you will understand the whole of maths also in a very easy and a very you can imbibe maths within you in a very nice manner. So it will give you a revolution of mathematics, not just in the representation of numbers, but in any field of mathematics, not just number systems, any field of mathematics. The idea, the concept of 0 is very important, and the concept is quite similar to the concept or the idea of 0 being used in the number system. So 0 enables vanishing, and this vanishing makes a whole lot of things possible in all the areas, in all the fields of mathematics. This vanishing makes a whole lot of things possible. Vanishing and moving up to another level. So this sort of things, you will see this idea comes back again and again in other areas of mathematics also. So restricting our discussion to number systems, so this 0 enables this vanishing and moving up a level and making it possible for the representation of as high quantity as desired with only a finite set of symbols at our disposal. So this is the wonder. This is the wonder of modern number systems. So if you don't know about 0, even then it will make you wonder that only using a finite set of numbers, finite set of symbols, we are able to construct as high a quantity as desired. That is really a wonder. However, this wonder is made possible because of another wonder, because of this wondrous idea of 0, which was put forward from our very land. So something to feel really proud about, being pursuers of science, pursuers of mathematics in some way, because engineering has a very strong mathematical foundation. So we need to be proud about this thing, but not just a shallow pride, but really understand how 0 has enabled the workings of the modern world. So like sometimes this happens that we see people around us who are really proud of something, But if you ask them what is there to be proud about it, they will not be able to, they will fumble and they will not be able to say many things about why they are proud. They will again counter you with a question. So you are not proud about this thing which is so Indian in nature, or so much of our national importance or something like that. But if you are proud of something, you must understand why you are proud of that. You must understand the significance of that particular thing and really feel that pride and be able to defend that pride if you are asked why you are proud about it, and enlighten the another person. So when from the time I understood about zero, this really made a very fascinating journey, and I had ever since my outlook to mathematics have changed actually with the revolution of how zero is such a powerful idea in mathematics. It enabled the entire mathematical foundation. Perhaps everywhere you will see the idea of zero and how it is actually contributing to so many things. So coming back to our number system, so these symbols combined together in a designated manner gives rise to the possible numbers representing all possible values. So this is what we already seen. So yeah, so concluding, 0 actually did not vanish. So it was there all through our discussion, however hidden behind plain sight, as if hidden behind plain sight. It is so subtle and its contribution is so immense. So one thing is it is subtle, it is hard to notice, and its contribution is through and throughout. That also makes it hard to notice. So if something is very close to your eyes, you will fail to notice it. Something which is all the like it is spread everywhere, then you will not be aware of it. So 0 is something like that. That's why it is referred to as the supreme cause, because the idea of the supreme cause or the idea of God is also something like that in our literature, in our Indian literature. So that's why it is often compared as the supreme of all the numbers. And if you look at all these definitions, all these descriptions, probably now you would understand why 0 can be described by all these things. So with that I will conclude the presentation. So thanks for your attention, and next from the next in the next lecture we will go more into number systems and see how we can work with number systems. Thanks.